Here we are going to solve for the result for the transformation of R2 vector 1, 1 and 0, 1 given these two situations already here. To do this, we are going to represent this vectors here 1, 1 and 0, 1 as a linear combination of these two vectors with a certain constants that make them possible. And then later, we are going to use a theorem which will allow us to take the result or the transformations of 2, 0 as 1, 1 and 0, 3 as 3, 3 as part of our process. Again, for t of 1, 1, we are going to represent first this vector 1, 1 as a linear combination of 2, 0 and 0, 3 using a 2, 0 plus b 0, 3 where a and b are element of the real numbers. In short, we are going to solve for this specific variables first so that we could come up with a correct process later. So with this, I do hope my space is correct here, but of course I still have more spaces below for our second item. So I have here 1 and 1. So multiplying that, we have 2a, and that's a times 0 is 0, plus b times 0 is 0, and you have here 3b. And then you have 1, 1 is equal to 2a plus 0, and 0 plus 3b. This would mean, because we have equal vectors now, the components should also be equal. You have 2a is equal to 1, a is 1 half, and I have 3b equals 1, so b is 1/3. In short, these are the values of a and b which could make this true and say that our vector 1, 1 is a linear combination of 2, 0 and 0, 3. Hence, we'll have this form here. We have 1, 1 is 1 half of 2, 0 plus 1/3 of 0, 3. If you're not convinced with that, of course, you can multiply. 1 half times 2 is 1. Then we have here 1/3 times 0 is 0. So 1 plus 0, we have 1 here, right? Same thing with the other. 1 half times 0 is 0. 1/3 of 3 is 1. That's why we have that. Now we are solving for the linear transformation of 1, 1, not just 1, 1 itself. So when we do this, we have the linear transformation of 1, 1. We'll do the same thing on the other side. Linear transformation of 1 half to 0 plus 1/3 0, 3. But we have the theorem which tells us that we can distribute this linear transformation here, since we know that it's a linear transformation, right? Okay. So if it's linear transformation, the transformation of the sum is equal to the sum of the transformations. So you have the transformation of 1 half to 0 plus the transformation of 1/3 0, 3. This is the idea or the definition of linear transformation. Aside from this, we have these constants here, so we can take them out. So you have 1 half the linear transformation of 2, 0 plus 1/3 the linear transformation of 0 and 3. So we have this already. We have this value or vector, and we have this vector as well. So substituting that, the linear transformation of 1 and 1 is 1 half the linear transformation of 2, 0, which is 1 and 1, plus 1/3, and the linear transformation of 0, 3 is 3, 3 given here. So the final result now, the linear transformation of 1 and 1 is multiplying that scalar. You have 1 half and 1 half plus 1 and 1, right? 1/3 times 3 is 1 and 1. So you have linear transformation of 1 and 1 is equal to 1 half plus 1 is 3 halves and 3 halves. This is the result for the first unknown, okay? Using the values of a and b here. But this a and b may not be true for this second step since we have different equivalents now here. But since still a and b is element of R, so if we're going to use it here, second step, so you have 0 and 1 must be a linear combination of vector 2, 0 and 0, 3. So you have 2, a 2, 0 plus b 0, 3. Again, A and B, sorry, A, B, element of real numbers. So you will have here 0, 1, that's 2A, 0, plus 0, and 3B. Equating them, or later, let's do it step by step. You have 2A and then 3B. So 2A is 0, that means A is 0. Okay? And you have 3B is equal to 1, B is still 1/3. That would mean, okay, the linear transformation of 0 and 1, let's not include the linear transformation first. You have 0 and 1 can be written as a linear combination of 2, 0, and 0, 3 with this following, what do you call this one? Constant. 0, 2, 0, plus 1/3 of 0 and 3. Of course, this will become 0, 1/3 times 0 is 0, so you will know that it's correct. So let's take the linear combination now. Again, the linear combination of the entire plus 1/3, 0, 3. Applying the first condition for linear combination, you have this 2, 0, plus 1/3, 0, 3. Then the constant will be moved outside. 0 times the linear combination of 2 and 0 plus 1/3 times the linear combination of 0 and 3. Okay. In short, the linear combination of 0 and 1 is 0 times the linear combination of 2, 0 is 1, 1, and for 0, 3 is 3, 3. Okay? 0 times 1 and 1 plus the linear combination, or 1/3 rather, and we have 3 and 3 here. So with this is, okay, 0 and 1. This is 0, 0, plus 1 and 1. In short, okay, pardon for that. The linear transformation for 0 and 1 is equal to 1 and 1. This is the result for the second item. Again, these were all made possible by first solving for the constants A and B, which could satisfy this linear combination here, as well as in this given example here. We're done solving with A and B. And then once we take the linear transformation of the first, the vector here, apply the concept of linear transformation with the sum and the constants. So for you to be able to get the values here, 3/2 and 3/2, and here 1 and 1. Okay? Thank you very much for watching.